Welcome to Study Loop.
This is the answer to Chapter 13, problem number 6 from the Smith Organic Chemistry textbook. And this problem is asking us to consider putting 2,2,4-trimethylpentane into a mass spectrometer. And we are told that the base peak occurs at a mass to charge number of 57. And we are asked to draw what that 57 represents, and to talk about why that's the most abundant ion. And so you could approach this problem really from two directions. What I did first was I considered the ion, the base peak at 57, and I thought about so this molecule only has carbons and hydrogens in it. And so what combination of carbons and hydrogens can get me to 57? And so C4H9 adds up to 57. As you can see here, I drew the math out in green. And then going back and looking at our original molecule, is there a bond that can break that will result in an ion with a formula of C4H9? And there is, and it's this bond. I've crossed it in red to show that it's breaking, and you can see that will give us 4 carbons, 9 hydrogens, and a positive charge on that fragment. So it is an ion. And then the remainder of the molecule I've drawn over here, there will be a lone electron on this carbon, and the rest of the molecule. And as for why this is the most abundant peak, because remember, the most abundant peak is going to be the base peak. And so we're told the base peak is at M to Z 57. And so that's the most abundant ion, in the mass tracing from the mass spectrometer. And so just looking at this fragment, we can see that it's a tertiary carbocation. And you should remember that tertiary carbocations are the most stable. And so it's really the only place in this molecule where a tertiary carbocation could form from breaking a carbon-carbon bond. And so since it's the most stable, it's going to form the most readily, and more of it will form than of any other possible ions. And so that's really, I guess, the other place that you could start at to approach this problem is to think, where could I cut this molecule to produce the most stable ion possible? And so working backwards like that will get you to the same answer. And then once you get this molecule, this fragment here, you'll see that it does fulfill our requirements of C4H9. And so that is the answer to problem